Good morning, good evening, good afternoon, every student. I'm teacher Shane from Kangaroo Study. Today, let's see a question from RMO 2025, round 1. Here is the question. The table below shows the number of days Cindy and Diana spent to complete projects X and Y. Given that they can work individually or together, what is the least number of days needed to complete both projects? First, we have to know what kind of problem it is. It is an engineering problem, yeah. And in engineering problem, there are 3 basic values we have to know. Let's introduce the first one here. For the first value here, it's talking about the amount of work you have to do. Let's take an example here. Maybe you have to make 3 cars or eat 8 apples. And that is the work you have to do in the engineering problem. This is the first value here. Let's see at the second value. The second value is talking about how long you spend on the work. Let's take an example again. Maybe you have to spend 1 second or you have to spend 1 day. That is pretty long or short. So for the value here, it is about time here. This is the second value we have to know. Let's see the last value we have to know here. It's talking about how fast to finish the work. So let's take an example here. You have to eat 3 apples in 1 day. And that's what we call work efficiency. And that's the 3 value we have to know about in engineering problem. Now let's take an example here. I know I have to eat 9 apples. And I have to spend 3 days to finish all of them. Then how many apples I have to finish a day averagely? Well, 9 divided by 3 equals to 3, so we know that I have to eat 3 apples in a day. Now let's see another example here. This is the amount of apples I have to eat. However, I don't know how many of them, so let's see as a whole one. I still know that I have 3 days to finish all of them. Then how many apples I have to eat per day averagely? We can use 1 divided by 3. We can get 1 over 3. So I know that I have to eat 1 over 3 amount of apple in this example. Now let's see here. We know about the values. Let's find out a special relationship between 3 of them. So first, let's see an example here. We have the time and work efficiency. I know that I have to spend 6 days, and I can maybe, for example, for a car, I can make 1 over 3 car per day. Then how many cars I can make in 6 days? We can use 6 times 1 over 3, and we can get, I can make 2 cars in 6 days. And as we can see here, if I have the time and I have the work efficiency, I can times them together to get the work. Let's see another example here. So I know that I have to make 3 over 4 cars, and my work efficiency is making 3 cars per day. Then how many time I have to spend to make 3 over 4 cars? We can use 3 over 4 divided by 3 equals to 1 over 4 day. So in this relationship, we can see that I have the work and I have work efficiency. I divided 2 of them to get the time I have to spend. Now let's see the last example here. I know that I have to make 1 card and I have 5 days to make this card. Then how many cards I have to make per day? I can use 1 divided by 5 to get 1 over 5. So I have to make 1 over 5 cards per day. And in this relationship, we can know that I have the work and I have the time. I also divided 2 of them to get the work efficiency. Now you may want to ask, teacher, how am I going to memorize all of this relationship? Now I'm going to tell you a secret tip. Don't tell everybody. It's only between me and you. So with this method, we can draw a pyramid to remember all the relationship. In this pyramid, we can see that there are work on the top of the pyramid, time and work efficiency at the bottom of the pyramid. If I want to get the work, I cover up the work and I use time times work efficiency and I can have the work. If I want to get the time, I cover up the time and I can use work divided by work efficiency to get the time. So in this pyramid, if the value is on the same level, we multiply them. If they are not on the same level, we use division here. Isn't that very easy? Now we know about the engineering problem. Let's get back to the question here. Now we know in this question there are two projects, Project X and Project Y. Now I want to know who is more efficient. Let's look at the Project X first. We know that Cindy have to spend 10 days to finish Project X and Diana have to spend 7 days. So Diana is more efficient in Project X. Now let's see at the Project Y. Cindy had to spend 16 days. However, Diana had to spend 20 days. Now we know that Cindy is more efficient in Project Y. Now we know who is more efficient, faster in the project. We got the faster guy to be in charge of the project. We know that Cindy had been in charge in Project Y and Diana be in charge in Project X. With Project X and Project Y, we don't know what amount of work we have to do, so we both see that as a whole one. I will use red bar to represent X and blue bar to represent Y here. Now we know how much work we have to do for Project X and Project Y. I want to know how many work had to be done per day. So let's see here. Diana spent 7 days to finish Project X. So for Diana, we use 1 divided by 7. We can get 1/7 Project X done per day. And for Cindy, we will use 1 divided by 16 to get 1/16 Project Y per day. Now this is the day 1 Diana and Cindy make the process. Day 2, day 7, and we know that here, Diana finished Project X. So Diana can help Cindy with here. Now I want to know how much work have done. We know that this is amount of work that Cindy have done. And what should we do to get to know how many work have left? We use 1 minus 7/16, so we can know that there are 9/16 Project Y to be done. So I now want to know how many work can be done a day. So let's see at the Project Y here. Cindy spent 16 days to finish Project Y and Diana used 20 days to finish Project Y. So we know that for each day, Cindy can done 1/16 Project Y per day, but Diana is only 1/20 Project Y per day. Now we add them together, we can have 4/80 plus 5/80 per day. That is 9/80 Project Y can be done per day. Now we know how many works is left and how many works can be done per day. What do we do to these two values to get the days that is left for finished Project Y? We use division! And after division, we know that there are only 5 days left to finish Project Y. And don't forget that on the day 7, we finished Project X. So I already spent 7 days for finishing Project X, and I spent extra 5 days to finish Project Y. So in total, I have 12 days to finish both projects. Then that is the final answer for this question here. After finish the question, let's do a little summary. For the summary, the first key point you want to know is about the engineering problem. There are 3 basic values you have to remember. First is the work, second is the time, and third is the work efficiency. Now let's see, the second key point you have to remember is that the faster person do the job. That is more efficient. Now let's see, the last key point you have to remember that is we can use the work that is left divided by the work that can be done per day. We can know how many days left for finishing the project. And here's the practice question that you can do it by yourself. And don't forget about that. Practice makes perfection here. And if you want to join Kangaroo Study to learn more math, scan this QR code and let's see you in the classroom. Bye bye.